this is going to be objective 16. We are going to find values of missing lengths of a triangle using our trig ratios. Okay, so again, some of this will seem very familiar, so it kind of just continues to pull what we already know and just add on just a little bit more to it. Okay. So I'm going to give you a second to go ahead and copy this down. Let me just really quickly, like we already know based on Sakatoa, right? Some old hippie caught a high tripping on acid, yes? So when you're looking at a right triangle, the sine is the opposite over the hypotenuse. Well, what's the relationship between sine and cosecant? What's the relationship? They are reciprocals. So doesn't it make sense if the sine is opposite over hypotenuse, then the cosecant would be hypotenuse over opposite. Any questions about that? Okay. Okay. So let's look at example 1. And we're going to find the 6 trig ratios of angle theta. Okay, so the only difference really in what we're doing here with triangles is you have to really look at the theta, because it may be this angle you're talking about, or it might be a different angle. Okay, so you have to know which angle you're referring to, and that's going to make whether it's opposite or adjacent or vice versa. So I'm going to make my list. Sine, cosine, tangent, cosecant, secant, cotangent. All right, so based on Sakatoa, what do we know the sine is equal to? The sine is when we're talking right triangles, that's when you can use Sakatoa. You follow me? It's got to be a right triangle. Okay, and I'm telling you right now, this is a right triangle. So based on what I gave you on the previous slide, what do we know the sine is equal to? The opposite over the hypotenuse, okay? So let's look. If I'm here at theta, which side is opposite from theta, Jacob? If I go across, the 2 is opposite, right? So this is going to make 2 over, the hypotenuse is the side that is opposite from the right angle, which would be 2 over 3. Okay, so our sine is equal to 2/3. Okay, how about our cosine? We know our cosine is equal to the adjacent over the hypotenuse, which would be equal to, which one? Adjacent means what? Just in general, if you looked up the word adjacent in a dictionary, what would it mean? Like if I park adjacent to Andrea, like in the parking lot. Beside. Does that make sense? Adjacent means beside. So, all right, so adjacent means beside. So which side is, now, if you look at it, both of these are beside, right? But you can't use the 3 because the 3 is known as the hypotenuse. So which other side is beside the theta? The square root of 5. So this one's going to be the square root of 5 over 3. Okay? And we know the tangent. Now there's 2 ways to get the tangent. If you already know the sine and the cosine based on what we tested on yesterday, how would I find the tangent? You could do y divided by x. What else could you do? You could do sine divided by cosine. You can mark those out and do what? Get 2 over the square root of 5, but then when you rationalize it, you get 2 square root of 5 over 5. But based on today's lesson, what do we know tangent is? Tangent is the opposite. Which one's the opposite? Opposite of theta. 2 over the adjacent, which would be square root of 5. But again, you rationalize it. Do you not get the same thing? So do you understand what I'm saying? Like there's more ways to do it. Based on today's lesson, you look at it as opposite over adjacent with the right triangle, but you can also use what you used last week. If you know the sine, you know the cosine, you can use sine over cosine, or y divided by x. Everybody with me so far? Okay, so cosecant, again, if it were me, if I know the sine, the cosine, the tangent, what would I do with cosecant, secant, and cotangent? Just flip them, okay? So you can use, I mean, if it makes you feel good to do today's lesson, you can use hypotenuse over opposite, you can use hypotenuse over adjacent, and you can use adjacent over opposite, but I'm just going to flip them. So what's my cosecant? 3 over 2. What would the secant be? 3 square root of 5 over 5. Very good. And what would the cotangent be? Square root of 5 over 2. Any questions on that? So, feels pretty similar to what we've been doing? Yes? Just adding on one little more element to it. So, I'm going to tell you that the cosine of A is equal to 3/4. The cosine of A is equal to 3/4. So, or not cosine of A, it's cosine of alpha. Here we go. So if we go back to this, this is the cosine of alpha, okay, equals 3/4. It doesn't matter which angle you put it at. You just need to put the alpha at one of the angles. Obviously, I'm going to make this our right angle, okay? Let me go back. I'm going to make this our right angle. So where do you want to put alpha at? Up at the top. Okay, so we're going to put alpha up here. Okay, there's my alpha. Looks kind of... No, it doesn't quite. It's like I can't draw it very well. It's a like it's like that. It's not connected. An infinity sign is like a full double circle. Okay, so kind of reminds me like a fish. Okay, there's our alpha. So my thought is this: sine, cosine, tangent, cosecant, secant, cotangent. All right. If we know the cosine is 3/4, and here's our alpha, what do you know about your sides? What's the cosine normally? Cosine is adjacent over hypotenuse. Okay, so do you know one of your sides? Okay, so which one would be the adjacent to this angle? Beside of it, the adjacent is going to be 3. Okay, and then where's the 4? Okay, that's your hypotenuse. That's 4. Okay, so I want you to take a minute, talk in your groups, see what you can figure out. We know this is 3/4. What would the other 5 be? Okay, so I really want you, versus me coming in and telling you, the thing that makes trig difficult is you have to see the whole picture. Does that make sense? You have to see how what we did last week relates to what we're doing today. Do you understand? And then you kind of have to like put it all together that it is all the same thing, but it's different things. Like I give you this and it's not exactly like what we did last week, but it still is, okay? And you also have to take what you know. I am going to treat this differently because it is a right triangle, okay? But I want you to understand that if you used sine squared x plus cosine squared x is equal to 1, you're going to get the same thing. So if you used what you did last week, so like when you get to it as we continue on, and I go back and I throw some of this at you, you know, I don't want you to be like, I don't know how to do this, like thinking there's only one way to do this. Does that make sense? It's like, figure out what you do know, what you can do, and go from there, and that there's more ways to do it. Does that make sense? Just because you don't remember like one little way to do it, there's another way to do it. Okay? So because this is a right triangle, I'm going to treat this as a squared plus b squared is equal to c squared. Okay? So these are our two legs, so it doesn't matter which one. I'm just going to do 3 squared plus b squared is equal to 4 squared. So I'm going to make 9 plus b squared is equal to 16. I'm going to move this over and subtract 9, so b squared is equal to 7. And when I take the square root, b is equal to the square root of 7. Any questions so far? Okay. A and B, A is a leg, B is a leg. It doesn't matter. I could have put the 3 for the A and B don't matter. C always has to be your hypotenuse. And these are great questions. That's what I want you to ask me. So that makes our other side square root of 7. So now if we use what we did in the first example, sine is going to be the opposite over the hypotenuse. So what's the opposite here? The opposite to the alpha is square root of 7 over 4. Okay, how many got square root of 7 over 4? How many did it with a squared plus b squared equals c squared? How many did it with sine squared x plus cosine squared x is equal to 1? Do you see what I'm saying? I'm kind of that you did it that way, and I did it this way. So you can see that it's the same thing. So when it comes to test day, it doesn't really matter which way you do it, okay? So we know our tangent, one way to think of our tangent is opposite over adjacent. So in this case, the opposite is square root of 7. The adjacent is 3. But another way you could think of it is sine over cosine. Does that make sense? And you can work it out that way. It's the same thing. You don't have to use SOHCAHTOA, but I would like for you to know that, because what if I use this as a relationship or analogy, like playing basketball. Like the goal is to get the ball in the hoop, right? If you know one way to get the ball in the hoop, like let's say I go into trials and I say, Coach, all I can do is layup. That's all I can do. I know that's the way I know to get the ball in the hoop. I can do a layup. Okay? Am I going to be a good basketball player or a bad one? Why? Because you need to know multiple ways. That's why I said you need to be able to look at this and say, oh, the Pythagorean theorem works here, and we can use SOHCAHTOA. But I also need you to say, oh, we know our Pythagorean identities with our trig functions, and so we know that we could use that too. You need to know multiple ways to do it so you can attack the problem at any angle. Does that make sense? Okay. All right, so cosecant. Now, I would tell you this. Cosecant, once I get to here, once I get these three, I would, if it were me, I would just flip them. Okay? So cosecant's going to be 4 square root of 7 over 7. Secant's going to be 4/3. And cotangent's going to be 3 square root of 7 over 7. With me? Okay. Any questions on that? Would it have been okay? Did I have anybody that labeled this angle as alpha? Is that okay? But when you did that, you would have labeled this as 3. You would have labeled this side, if you labeled the alpha down here, you would have labeled this as 3, this is 4. You would have solved over here. This would have been your opposite, square root of 7. Again, it's not going to end up mattering which way you do it, okay? So it doesn't matter where you put your alpha, okay? So we're using alpha and beta right now, okay? So I want you to find the sine of alpha and the cotangent of beta. Then question 2 says I want you to find the tangent of alpha. Oh, this should say, I'm thinking this should say secant, sine and secant. Let me change this because we already got cotangent of beta. Let's make this a secant, like beta. Sine of alpha, secant of beta. Okay? Take a minute and look at each one of those if you need it. Okay? So the question I got over here, and I think I got it over here too, was I don't know which number. The first thing I'm going to do is I'm going to find this piece right here. Because I can't do all this. I'm going to need all three pieces to find my adjacent, opposite, and hypotenuse. So which two are the legs of the right triangle? The legs are the sides that form the right angle. So which two form the right angle? 3 and 5. That's going to make A and B. It does not matter which one's A, which one's B. They are both equally legs. Okay? So those are your legs. So when I plug in to A squared plus B squared is equal to C squared, I'm going to do 3 squared plus 5 squared is equal to C squared. Because the C has to be the hypotenuse. Always? Yes, always. Okay? So 3 squared is 9. 5 squared is 25. C squared. So this is going to make 34. And then when I take the square root, C is going to be the square root of 34. Any questions on that? So let's look at the relationship between the sine of alpha and the cosine of beta. Okay? So let's look at alpha. Sine is what over what? Sine is opposite, which is 3 over the hypotenuse, which is square root of 34. So it's going to end up being 3 square root of 34 over 34. Okay? Let's look at the cosine of beta. So you have to go to your beta. Cosine is adjacent over hypotenuse. So which side's the adjacent? 3 over the square root of 34, which is going to end up being 3 square root of 34 over 34. So what's the relationship? The sine of this angle is going to end up being the exact same as the cosine. So it's kind of, Miranda said, oh, that's what you just said over here a minute ago. If I said, you know, if this was alpha up here, then that makes this 3 and this square root of 7. But if this is alpha down here, then that makes this 3 and this square root of 7. They're just opposite from each other. So if you look at the two, sine and cosine, the opposites and the adjacent sides, right, then they're going to end up being equal. Okay? So let's look at the tangent of alpha. So if we look at the tangent of alpha, tangent is known as opposite over adjacent. What's the opposite? 3 over 5. Okay, so let's look at the cotangent of beta. So the cotangent of beta, now you could find the tangent of beta. Tangent of beta is 5 over 3, so the cotangent would be 3 over 5. And so they're going to be equal. Okay? The tangent of this angle is going to be the exact same thing as the cotangent of that angle. Okay? So what do you think about the secant and the cosecant? They're going to end up being equal as well. So secant of alpha, secant is the reciprocal to what? Cosine, right? Secant is the reciprocal to cosine. So maybe find the cosine of alpha. What's the cosine of alpha? It's going to be 5 over, so the reciprocal of that would be square root of 34 over 5. Same thing with the cosecant of beta. Cosecant is reciprocal to what? Sine. Sine is opposite over adjacent, opposite over hypotenuse, excuse me. So the reciprocal to that would be square root of 34 over 5. Did you follow that with me? Do you understand that it's just going to be opposite of it. Okay? Okay. All right, so let's switch gears really quickly. Okay, let's learn how to put these into our calculators. If I want to know the sine of 17 degrees, the first thing you need to do is you need to put your calculator in degree mode, which I think you did in geometry when you did it. So if you go to your mode button, does everybody know where your mode button is? Do I need to pull up my calculator on the board? Okay. Go to your mode. Go down to where it's the third one down where it says radian. You need to arrow over and highlight the degrees. Any questions on that? So you need to put it in degree mode. That's just make sure it is. If yours is already in degree, then you're good to go. Okay, does everybody understand? It will mess up. Like if you don't have it in degree mode, it's not going to work. No. It will not mess up anything. So I think you can keep it in degree mode. Okay, so what we're going to do is we're going to put in, I'm going to turn the lights on so you can see your calculator. So everybody sees the sine. So you're going to put in sine, and then you're just going to put in 17. We want the sine of 17, and that's degrees because we've already told it that these are degrees. Okay, so the sine of 17 degrees is equal to 0.2923717047. So you don't need to, let's round to the nearest, let's do 4 places. Okay, let's do 4 places. So if I were doing this one, 2924. Okay. So if I wanted to know, another way you could do this, we know that the reciprocal of sine is what? Is cosecant, okay? So if I wanted to know the cosecant, and actually, I don't like this. Let me fix this. I want to do this 1 over the sine. If I wanted to know the cosecant of 17 degrees, okay, and these aren't going to be equal. I'm going to just kind of, don't draw the equal sign here. I don't like how this slide's laid out. Okay, if I want to know the cosecant, you can't put cosecant in the calculator. Do you see a button that says cosecant? You've got to change cosecant to sine, right? So what do we know cosecant is? What's the reciprocal of cosecant? Sine. So if I want the cosecant of 17 degrees, then I'm going to do 1 divided by the sine of 17 degrees. That would be equal to cosecant. Do you understand? Because it's the reciprocal. So if you put in your calculator 1 divided by the sine of 17, that's going to give you the cosecant. What's the cosecant of 17 degrees? So this one's going to be 3.4203 if I did 4 decimal places. Okay? So if I want to know the secant of 88 degrees, we can't put in secant. But what is the reciprocal to secant? Cosine, that's where this comes from. So I could put in 1 over the cosine of 88, and that would give me the secant of 88 degrees. So 1 divided by the cosine of 88 is going to be 28.6537. Okay? Again, if I want to know the cotangent of 1.54 degrees, I can't put in cotangent, but I could put the reciprocal of that, which would be 1 divided by the tangent of 1.54, which is going to equal what? 37.1961 if you rounded it. Okay, any questions on if you want to do the reciprocals, you just do, if you want the cosecant, you do 1 over the sine. If you want the secant, you do 1 over the cosine. If you want the cotangent, you do 1 over the tangent. Everybody good? So my question to you is this. Let me keep going. Not too much more. All right, so let me change this slightly. Okay. I want you to find the missing variables and state your answer correct to 5 decimal places. Okay? So I'm giving you 30 degrees. I'm giving you 30 degrees. Is everybody with me so far? I cannot use a squared plus b squared equals c squared in this case. Why not? Well, I'm going to tell you it's a right triangle. Let me put the little right angle. It is a right triangle. In order to solve, oh goodness, go back. You need, you can't solve for A and B at the same time, right? You can only solve for how many variables? In order to use the Pythagorean theorem, you would have to know how many of the sides? 2 of the sides. We only know 1 of the sides. So we're going to have to use something else. So we do know we have 30 degrees. So you can't solve for A and B at the same time. Which one do you want to focus on? B. Okay, so let's solve for B. What's the relationship? Let's not use A. I'm going to throw him out the door for just a second. I'm going to kind of ignore him. Let's use the clues that we have. I know I have a 30 degrees here. And I know I have B that I need to find. And I know that this guy is 12. So what's the relationship between 30 degrees and this side? Which side is this? This is the adjacent side to the 30. You with me so far? What's this side? The hypotenuse. So which trig function would pull it all together? The cosine. Everybody agree? I could say that the cosine of 30 degrees is equal to what over what? It's equal to b over 12. Very good. It's the adjacent divided by the hypotenuse. So can I give you about a minute and a half and see if you can solve for b? I've shown you how to put 30 degrees cosine of 30 in your calculator, and I've shown you how to solve equations. So take a minute and see what you can do. Take a look at this. So what would I do to solve for both sides? I'm going to times by 12. Okay? So 12 times the cosine of 30 degrees is equal to b. Any questions so far? Okay? So when you do this, you get rounded to the nearest 5 places, 10 point, I don't have my calculator. 39230. Okay. Any questions about that? So there's your B. Okay. 10.39230. All right. If I look at finding A, so let's see if it's the same. So let's look at A this time. What's the relationship between our 30-degree angle and A? And if it were me in this case, I'm still going to use the 12 because 12 is a whole number. It's going to be a little bit easier to deal with than the decimal. So what's the relationship? It's the sine of 30 is equal to A over 12. So I can times again by 12. So 12 times the sine of 30. So what's A going to equal? 6? 6 whole? 6. Okay. Any questions on that? Yeah, your hypotenuse should still be the largest. We do know that relationship. Okay, the hypotenuse should still be the largest. So, I'm going to stop right there for today.